Hello, this is Shankar Datta. Today, I'll explain some problems from Codechef December Challenge 2020 Division 2. The first problem, even pair sum. Here, you are given two positive integers a and b. Find the number of pairs of positive integers x, y such that x will be 1 to a and y will be 1 to b and x plus y will be even. Now see, in case a and b both will be even, then for each odd x combination there will be 3 odd x combination, and for each even x combination there will be 3 y even combination. So it is b by 2, but x is a 6. So in this case the possible pair will be a into b by 2. Okay. Now if b is even but a is odd, the same thing will happen for each odd x. There will be 3 odd y, and for each even x there will be 3 even y, but x will 1 to 7. So the pair will be a into b by 2, the same. But in case a is even and b is odd, now for each x odd combination there will be b by 2 plus 1 number of y combination. But in case of x is even, there will be just b by 2 number of even y. Now in this case, and how many even conditions are there? 1, 2 and 3, a by 2. And how many odd combinations are there? 1, 2, 3, again a by 2. So in this case pair will be a by 2 into b by 2 for the even condition, and for the odd combination a by 2 into b by 2 plus 1. Okay. And if both of them are odd, then the same thing, that for odd x it will be b by 2 plus 1, and for even x it will be b by 2 only. But how many odd combinations are there? 1, 2, 3, 4. So a by 2 plus 1. And how many even condition? 1, 2, 3. So just a by 2. So if both of them are odd, then a pair will be a by 2 into b by 2 for the even, and for the odd a by 2 plus 1 into b by 2 plus 1. Okay, this is the answer. Now see the example. If a is even, b is odd, 8 and 9, I use this even odd, this formula, and the answer is 36. Check it. This example 8 and 9, this is 36. So it is correct. And one thing must check, that constants a and b, the range is up to 10 to the power 9. So in case of Java it must be a long value. Okay, so it is very simple. You just need to check is b is even or odd. In case of even, then I don't need to check a is even or odd. I just use this formula, because both of them are same, both case. But if b is odd, then I will check if a is even, I will use this formula, and if a is odd, then I will use this formula. Okay. Now the second problem, vaccine production. Here two companies are producing vaccine for COVID. Company A starts producing vaccines on day D1, and it can produce V1 vaccine per day. Company B starts producing vaccine on day D2, and it can produce V2 vaccines per day. Now currently we are on day 1. We need total P vaccines how many days are required to produce enough vaccines. I need to find out the time. Okay, here two possible condition. If it may be that the both of the company will produce vaccine at the same day, or D1 will be greater than D2, or D1 will be less than D2. In case they will produce vaccine from the same day, so in this case it is day 2. So here the time will be needed. We are in day 1, but they are starting from day 2. So D1 minus 1, we already spent 1 day for that. Then from day 2, this will produce total 7 and 5. Total 7 plus 5, 12 vaccines. So total vaccine will be V1 plus V2. This is 12. So they can produce 12 vaccines per day and needed P vaccines. So it will be just P by V. The time will be P by V. But see, here it will be 100 minus 12, 8. As it is integer, so it cannot have any fraction value. But 8 into 12, 96, it still need 4 more vaccine. So we must check if there is any remainder or not. If it will not be 0, then the time will be just increased by 1. And if there is no remainder, so then just this will be the answer. Okay. Now in case this will happen, here the company B will start producing vaccine first from day D2. Okay, the time it will be D2 minus 1. Then before the day 4, in this day 2 and 3, the company B will produce vaccine alone. It will be, so the vaccine will be D1 minus D2 in this time, and that vaccine will be produced per day V2. So it will be 4 minus 2, 2 into 7, 14. So we already have 14 vaccines. The P will be P minus V. This is 100 minus 14, 86. Now from day 4, both the company will start producing vaccine together. So from day 2, they will produce 7 plus 5, 12 vaccines per day. And we just need 86 vaccines. So the time will be needed P by V1 plus V2. This will be 86 minus 86 divided by 12. Okay. Again, we need to check, is there any remainder? Here, if it will be not equal to 0, then the time will be increased by 1. Okay. So the time total time will be so it is from when the vaccine will be started, then the time in between D1 minus D2 plus this P by D1 plus V2, and if it will be, it has a remainder, then it will just add 1 with that value. Okay. Now check this condition. Here the company A will produce vaccine first, so the time in this case there will be no wasting time because they have started producing vaccine from day 1. It will be D1 minus 1 will be 0. Now before day 4, in this 1, 2 and 3 day, it will produce 10 vaccines per day. So the V will be D2 minus D1 into V1. This is 3 into 10, 30. But see, they just need 15 vaccines. So already we have enough vaccines. We don't need this much time. And it is confirmed that just with the help of company A, in within the day 4, they can produce enough vaccine. So if V will be greater than or equal to P, in this case, I'll just do the P by V1. It will give me the answer. And I must check that if there is remainder or not. If P mod V, if it has no remainder, then nothing to do. And if it has any remainder, then I'll just add 1 with it. Okay. So after doing this part, I must check this if condition. If this V is greater than or equal to P, then it will be do in this way. And if it will not be greater than or equal to P, that case happened in this example, then in between the else part, these things will be done. So in this way, it will be solved this problem. Okay. Now the third problem, vaccine distribution, that the vaccine is already come. There are n peoples in this safe land. The age of these people are A1 to AN. The hospital only vaccinate up to D people per day, and anyone age is greater than or equal to 80 or less than equal to 9 is considered to be at risk. On each day, you may not vaccinate both a person who is at risk and a person who is not at risk. Now find the smallest number of days needed to vaccinate everyone. Okay, there is 10 people and these 3, and the age of the people will be in this here. So at first I need to check how many people are there who are at risk. If AI will be greater than or equal to 80 or AI will be less than or equal to 9, then I will count it as the people at risk. So the time 1 will be the count by D. This much time will be needed. Here count will be 1, 2, 3, 4. So it will be 4 by these 3, and time 2, this will be the remaining pupils. This is n minus count by D. This will be 10 minus 4. This is 6 by 3, 2, and here it will be 1. But the total will be time 1 plus time 2. But I must ensure is there any remainder value of count by D. If it has any remainder value, it is not equal to 0, then I just need to add 1 with this total, and in the same way I will check is there any remainder value for n minus count, the rest people who are not at risk, mod D. Here if it has any remainder value, then it will add 1 again with the total. So in this way this problem need to be solved. Okay. So I think you have understand the problems and understand how to solve it. If you have any doubt, then please comment it. And if you want the answer, as the competition is not ended, so I cannot give you the answer right now, but after the competition if you comment it, I'll give you the link of my answer. So thank you for watching my video.